Hi, my name is Philip and I'm on PowerSync's product team. In this video, I'll be covering the architecture of PowerSync, a cloud platform that provides plug-and-play data syncing between SQL databases and apps. First off, let's cover some background context. Many applications are architected in an online-first way where data is read and written synchronously with the backend database. Now, this approach works well if the use case can require users to always be online when they need to interact with app data. But when users need to access data throughout periods of intermittent connectivity, this approach breaks. And this is where PowerSync comes in. PowerSync is a flexible SQL-based toolchain for creating offline-first apps. PowerSync consists of a cloud service which connects to your existing SQL database and automatically syncs data with a local database on each user device. Developers use an SDK to interact with data on device. Here's how it works. The PowerSync cloud service connects to your SQL database where it reads your schema. It'll also read data contained in sync tables, more on those in a second. Developers configure sync rules to specify how data gets filtered for users. Sync rules allow developers to configure that only certain data from certain tables, columns, and rows get synced to certain users. PowerSync reads a database changelog. Every major database like MySQL, Microsoft SQL Server, and Postgres have a feature that allows you to create a changelog which automatically records all changes that happen in the database. Once that feature is enabled, the PowerSync cloud service will read that log and populate what we call sync tables. Sync tables are a couple of tables that are added to your database schema and are populated according to your sync rules. Again, sync rules govern which data would be synced to which users. Developers would include the PowerSync SDK in their app project, and this SDK exposes an in-app SQLite database which is automatically kept in sync with your backend SQL database, including data and schema. When data gets modified on the user device, the SDK saves that change in the local SQLite database on the user device. And to sync those changes back to the backend database, the SDK places them in a queue, which executes as and when a user has network connectivity. Writes are made through your existing backend API in order to leverage any data validations and business logic which already exist in your backend application. In terms of authentication, the PowerSync SDK retrieves a JWT from your backend API and uses that for authentication. In this way, PowerSync's architecture enables two-way data sync. Data is synced from your SQL database all the way to user devices, filtered based on sync rules. And data modifications are synced back from user devices to your SQL database via your backend API, as and when users have network connectivity. That's it for this PowerSync architecture overview. Thanks for listening.